Welcome back to the Explainer. So today, we're diving into the absolute critical finishing touch in rotating equipment installation. We're talking about coupling installation. You know, if you've ever stood there and wondered how the massive amounts of energy generated by industrial motors actually get put to work to pump fluid or compress gas, well, you're in exactly the right place. We're going to break down this vital mechanical link step by step. And don't worry, we're keeping it crystal clear, so even if you're stepping onto a plant site for the literal very first time, you'll be able to follow right along. Now take a look at this number 23. In the massive, highly detailed manual for installing rotating equipment, coupling installation is step 23. It is the absolute final step. Think about that for just a second. Before a worker even touches the coupling, engineers have gone through 22 grueling, rigorous steps. They're checking foundations, chipping concrete, doing precision grouting, running the motor solo, and just obsessing over microscopic alignments. All of that immense effort, it culminates right here, step 23. So here's our quick roadmap for today's explainer. We'll start with the big picture, the final step for rotating equipment. Then we'll cover what a coupling actually is, look at the different types, walk through the installation process itself, and wrap up with safety first, the coupling guard.
All right, let's jump straight into section 1, rotating equipment, final step, taking a look at the big picture.
You can really think of coupling installation as the grand finale of a giant mechanical symphony. Basically, you have two main actors sitting out there in your equipment skid. You've got the driver, which is usually your electric motor generating the actual power, and the driven, which is typically your pump or compressor doing the heavy lifting. Now, for weeks, construction teams have been out there making sure these two massive pieces of equipment are perfectly leveled and anchored right to the ground. But up until this exact moment, they are completely isolated from one another. This is the moment the entire system finally becomes capable of running.
Moving on to section 2. What is a coupling? Let's define this essential connector.
Put simply, a coupling is a mechanical device that connects two rotating shafts together at their ends, and its sole purpose? Transmitting power. That's it. The motor spins, the coupling catches that spin, and it transfers it directly over to the pump. Without it, your motor is literally just spinning uselessly in the air, and your pump is just sitting there doing absolutely nothing. It's the ultimate team-up. Actually, imagine the motor and the pump as two completely separate islands. The coupling, that is the bridge built right between them. But as you can guess, in the real world, building that bridge isn't always perfectly straightforward, right? As you see here, the shafts might have a vertical offset where one is slightly higher, a horizontal offset, or they might even sit at a slight angle to one another. We call that angularity. Which perfectly leads us into section 3, the types of couplings. We'll look at rigid versus flexible. So out in the field, we basically have two main players, rigid couplings and flexible couplings. Now, a rigid coupling is exactly what it sounds like. It's a solid, totally unforgiving connection. It demands absolute 100% perfect alignment, allowing basically zero movement. But let's be real, out in a messy, changing plant environment, perfect is almost impossible to maintain once the heavy pipes are connected and the temperatures start shifting. And that is exactly why we primarily rely on flexible couplings. A flexible coupling is actually engineered to accommodate those slight misalignments between the shafts and really absorb the mechanical shock of operation. So why does this flexibility actually matter so much? Well, remember those alignment challenges we just talked about? A flexible coupling gracefully handles that parallel offset. It accommodates that tricky angularity. But honestly, most importantly, according to our engineering standards, it reduces system vibration. Look, if you bolt two slightly misaligned shafts together rigidly, they are going to literally fight each other thousands of times a minute. That creates massive, violent vibration that just destroys bearings and seals. By bringing in a flexible coupling, you prevent that destructive vibration and massively extend the lifespan of your really expensive rotating equipment. Okay, let's get into the how-to with section 4, the coupling installation process. Here's a step-by-step guide. The whole process is incredibly methodical. Step 1 is the alignment check, and we'll actually talk more about that massive hurdle in just a second. Step 2 is key insertion. Basically, the shafts usually have this little slot in them, and a metal key is inserted to lock the coupling to the shaft. That way, it doesn't just slip when it starts spinning. Step 3 is mounting the coupling hubs onto both the motor and the pump shafts. And finally, step 4 is the fastening. That's bolting the two halves of the coupling together to officially complete our bridge. But hold on, before you go tightening down those final bolts, there's a really strict quality control gate you have to pass. On this field inspection form, the crew is meticulously verifying tolerances. You'll see checks for shaft alignment, DBSA, which stands for the distance between shaft ends, and something called soft foot. Soft foot is just like when you sit at a wobbly restaurant table, meaning the machine isn't sitting perfectly flat on its base. The tolerances here are incredibly tight, sometimes just fractions of a single millimeter, dictated by really strict international codes like API 686. If the gap between the shafts is wrong or the alignment is out of tolerance, the coupling simply cannot be installed safely. No way! You have to go all the way back, adjust your shims, and fix the alignment first. And finally, we arrive at Section 5, Safety First, the coupling guard, protecting the worker. Now, take a look at this brilliant orange steel plate. I promise you, it is not just for decoration. This is the coupling guard. You might think, just based on the name, that it's designed to protect the coupling from getting damaged by the outside world. But its true purpose is exactly the opposite. It is there to protect people from the coupling. In absolutely any plant environment, finishing the mechanical coupling but failing to install this guard means the job is basically 0% complete. Because think about it, when that pump is finally running, that connected shaft isn't just turning. It becomes a high-speed rotation zone, often spinning at thousands of revolutions per minute. It is a terrifyingly extreme danger zone. If a worker just brushes past it, a loose sleeve, a lanyard, or a work glove could be instantly caught and wrapped around that spinning shaft with incredible force. That bright orange color? It's a universal industrial signal literally shouting, "Danger! Keep your hands out!" So I want to leave you with this final thought. We've just spent all this time obsessing over the precise engineering, the tight tolerances, the tricky offsets, managing the vibrations, all just to get this massive machine to run beautifully. But would you invite a catastrophic safety disaster by running that perfectly tuned system without its coupling guard? Of course not. The absolute true final step of rotating equipment installation isn't just about making the machine work, it's about making sure the humans working around it get to go home safely at the end of the day. Thanks so much for joining me on this explainer. I really hope this structured breakdown illuminated exactly how that crucial power bridge between the motor and pump is built, and exactly why every single step matters. Stay curious, keep learning, and I'll catch you on the next explainer.